Recently I had some trouble with charging USB devices. Sometimes it takes longer, sometimes it's quicker. And I never had a clue why that happens. And this could be the cable and stuff like this. And to find out more details, I purchased this USB tester here. And as you see, it's a neat little device, has a nice color LCD display, and yeah, so I can check what's going on. So I want to test this guy out here. Let's see what it's capable of. When I take, for example, this power bank and I want to charge it, I just plug it in. So this is the cable to the power supply, and here's the output. And currently I'm using USB-C, as you see, but it's also possible to input USB-A and output USB-A, and it's also possible to input micro USB connector. So it's pretty neat. Okay, so and as you now see, the display is showing that we draw some current. It's about 1 amp, so that's okay. That's the usual standard. And we have 4.8 volts. That's a bit low. So that would mean that it takes a bit longer. But okay, the power bank is pretty full already. So yeah, maybe this is the cause why the current drops now. And you see here that it also counts the energy that's input to the power bank or output from the USB tester. So you see, now we have output 21 milliampere hours. The energy display, it's still zero because there's not much energy output. But later on I will discharge the power bank and then we will see that. And it also shows here in the red color the output power wattage. So it's about 3.8 watts. And there are several different displays I can switch through here. And it's pretty neat that it has an oscilloscope function. So you see that there is some flickering on the voltage and the current. So the yellow line represents the voltage level and the other one is the current level. So now it has switched to another rating, display rating or scale. So, but this is okay. But sometimes a charger can be faulty because maybe the capacitor inside tried out and then there is much more flickering. So that is almost nothing here. But it's good that I can see that. So that's a good thing to find faulty USB chargers. Okay, what do we have else here? Okay, that's the display of the data signals, if there would be some data signals. But of course, as we just charge the power bank, there is no data signal. So it's flatline. Okay, then we see, okay, it's obviously from China here. That we can enter some system settings, but I won't do that now. I just leave it as it is. And that's the overview display. And you see that, 4.9 volts are output and 0.68 amps. And there in smaller characters, you see there is the wattage, 3.2 watts. And now we have 3 0.3 watt hours, and that the internal CPU has a temperature of 24 degrees centigrade, and that we have 64 milliampere hours output, and there is the impedance, so that's 7.7 ohms, and that means the resistance that it measures. And also it just shows the charging time in this case. So that's also pretty neat. So I see how long it takes for comparison. Let's see what's the next one. Yeah, there's again the voltage, the 5 volts. There's V plus is almost 5 volts, V minus is of course 0 volts, and then we have D plus and D minus. That's the data lines, and they are flat, as I said before. So it's another overview display. And that's the same overview display in Chinese letters. That's another overview display. With basically the same infos. Okay, and then we are back. Okay, as the power bank is full, I will now change this, and then the power bank feeds the power, not the 5-volt charger. So I just use this output here. And the USB tester starts up, and then I output here the power and connect it to a load. But it's more handy not to use USB-C in my case here. I just use the USB-A output. And I just plug it to my phone. And then I can reset the display here by pushing the knob that is here. And you see it's now 0 again, all values are zeroed, and the measurement starts. And you see that also the power bank outputs a voltage of 4.84 volts. Because this is very interesting, because the voltage makes a big difference. And the nominal voltage is 5 volts, and if it's just below 5 volts, it's okay. But in my experience, if the voltage is a bit above 5 volts, so for example 5.1 volts or 5.2 volts, the charging is much quicker. So that's an important value to find out why charging your phone or whatever you want to charge is slower. So a voltage of 4.8 volts means it's slower. So use this USB tester to test the capacity of a power bank. For this, I just feed the USB tester from the power bank here. Okay, it starts up. Just make sure by pushing the button here that it's reset to 0. Okay. We see that without load we have exactly 5 volts. And here I have 2 resistors in parallel, that's 10 ohms and 10 ohms. So in combination it means 5 ohms. And 5 ohms on 5 volts means 1 amp of current. So I discharge it with 1 amp of current. And the cable just runs here from there and comes here now. And I go here to the USB output and plug it in. So instantly you see that the voltage drops down. But of course there's also this blue cable here that could also cause some voltage drop. So now these should get a bit warm here. We have 0.75 amps. Of course, just 4.7 volts means not 1 amp. But you see that the milliamps display is ticking here. So that's 10 milliamp per hours, and now it's 11 milliamp per hours. So that will start to tick through until the USB power bank switches off. And in another display we have also the discharge time. Yeah, there it is. So it's now discharging for about 2 minutes now. And yeah, I will let this just run and I will see how much milliamp hours is inside this power bank. It's rated as 5000 milliamp hours power pack. So let's see what it really is. So here we are at 2356 milliamp hours, and as you see we have just one LED left, but it's still running, and I will let it run until it will switch off, just switch off the load. And yeah, I've added another 15 ohm resistor to speed things up, because yeah, now we have a current of around about 1 amps, and before it was 800 milliamps or so. So it takes very long to discharge the power bank. So let's see how long it takes completely and how much capacity it will contain. Okay, now it has turned off. The last LED was blinking for a few seconds and then it just shuts off. And yeah, let's see. Now the display is dark, of course, because there's no power coming from the power bank now. But when I switch the power source to a charger, which I have to plug in, there it comes on again. I will remove the load, and then we see we have drawn 240.74 milliamp hours and 12 watt hours. So let's say, okay, it's roughly 2500 milliamp hours. And yeah, they said that it should be 5000 milliamp hours. That's not exactly the same. It's about the half of it. So maybe they have just stated that the capacity of the internal battery cell inside that power bank has these 5000 milliamp hours. And of course there are losses, because to generate the output there must be a switching power supply between the cell and the output. And yeah, obviously there are a lot of losses. Okay, that's a bit disappointing, but good to know that it's only half of the stated capacity here inside the power bank. Okay, now I reset the values to 0 again, because now I want to charge the power bank, and I want to check how much difference it makes to use different cables. Okay, for the connection between the USB digital tester and the power bank, I just have this USB-C cable, but that cable here, which is micro USB, that goes to the charger. Yeah. Let's see. Now we have 4.8 volts and 1 amp. That's okay. But I have another cable here on hand. It was a cheap cable. Let's see how this is, or how this performs in comparison to the blue one. I just disconnected. So from the charger. And then again, we go in. And I connect it to the charger. And you see, we have just 4.64 volts instead of 4.8 volts. So that's roughly 200 millivolts of voltage drop inside that white cable now. And the white cable is even shorter than the blue one here. So obviously they used very, very thin copper wires inside that white cable. And I know of cases where they also use just steel wires to conduct the current, and steel is of course a very bad conductor, especially compared to copper. So that's also interesting to see, and that's where the USB digital tester is very handy, because yeah, otherwise it's not easy to see. So I don't want to use that cable, because it does not only mean losses, but it also means that the charging would take considerably longer. I don't want that. So I connect again the... Oh, let's see, I have another cable. Okay, I have another cable. It's also white, but it's, yeah, should be better. I think so. Let's see, I will connect it to the USB tester and to the charger. Oh no, it's also not so good. Just 4.6 volts. That's bad. And it just draws 0.35 amps. So that's not what I want. No. So I just reconnect the blue cable. And it's, yeah, really amazing. I bought this cable on AliExpress because I wanted to have a longer cable for charging my smartphone, for example. And yeah, it performs pretty good. I mean, it was a bit more expensive, or slightly more expensive to the other white cable. But I think it's worth the money, and it's cheaper than buying it at the local store. So again, you see it's back to 4.8 volts, and we have 1 amp of current for charging. So obviously, this small voltage change from 4.6 to 4.8 volts means that the charging current drops from 1 amp to much less. So yeah, it would take ages to charge this power bank with that crappy cables. So it's really important to, yeah, just use quality cables like this one here. And to see that, yeah, this USB digital tester is really useful to me. There's just one special thing about it. When you want to use the Type-C input, like I do now, I will connect it to a USB charger. You see, nothing happens. The display does not come on. So, yeah, there comes the special part. There's a kind of dongle supplied, and you have to insert this into the USB connector. When I now connect a load, for example, the power bank here, you see that only then the display comes on. So that's special on the USB-C input. And to my knowledge, this is caused by the protocol of the Type-C interface. There needs to be some data transferred, and yeah, so only with that dongle type thing here inserted to the micro USB port, which gives some protocol infos or whatever, and a connected load. Only then the USB tester comes on. I mean, that does not really bother me because, yeah, otherwise the USB digital tester is useless. So you need a supply and a load. So yeah, it's just important to know, because otherwise you could wonder why the USB digital tester does not come on. So don't throw away this little device here. And, okay, as you see, when the connection is established, the dongle is not necessary. So in my opinion, this USB tester is really useful, especially for determine if a USB cable is good or lossy, and also to see how much capacity a power bank has. So yeah, if you also think this is a good device, I will put a link in the description. And if I find it again, also for this cable here, because yeah, it was cheap and it's long and yeah, not so lossy. So yeah, I will put also a link in the description. If you're not already a valued subscriber, you have now the chance to become one. And yeah, please donate. I really miss you. And yeah, give me a thumbs up. Have a good time, and I will see you next time. Bye bye.